Hello, now we are going to discuss about TensorFlow. A short history of neural networks. In 1957, one-layer neural network. In 1959, first neural network to solve a real-world problem, that is, eliminates echoes on phone lines. In 1988, backup propagation, learning a multi-layered network. Short history of neural networks. Autonomous driving car using neural network in 1989. In that same year, another one paper, successful application to recognize handwritten zip codes on made using a deep network. In 2010s, near human capabilities for image recognition, speech recognition, and language translation. Perceptron, invented by Frank Rosenblatt, simplified mathematical model of how the neurons in our brains operate. Here, if you are seeing here, in from x1 to xn, weightage w1, w2 up to wn. For example, x0 equal to 1, weightage w0. In this summation, sum from I equal to 0 to n, summation of wi xi, wi xi, w naught x naught, w1 x1, w2 x2 up to wn xn. After integration, output 1 if summation of I equal to 0 to n, wi xi is greater than 0, otherwise 0. Perceptron could implement and or but not XOR here or function, here and function, here not in XOR function. Hidden layers can find features within the data. This is hidden layer within the data and allow following layers to operate the features. Can implement XOR gate. Learning, back propagation, training, large n. Inference, smaller varied n. Forward, backward in training. Here output coming, then error, but we need human face, so then training going on. In smaller varied n, inference forward only. Here not available backward. So here we got human face. Deep learning already claiming big success. From approximately 2011 to 2015, now we are getting error 3.46 from 25.8. In 2014-15 also 6. Half of now after in 1 year 3 approximately 0.5% increased. Deep learning already claiming big success. Number of developers, researchers exploding. A zoo of tools and libraries, some of questionable quality. What is TensorFlow? computation using data flow graphs for scalable machine learning. Open source library for numerical computation using data flow graphs. It is available open source for numerical computation using data flow graphs. Developed by Google Brain to conduct machine learning research based on this belief used internally at Google since 2011. TensorFlow is an interface for expressing machine learning algorithms and implementation for executing such algorithms. In machine learning algorithm, for expressing purpose, it is using it as interface, and we can implement for executing such a algorithm also. What is TensorFlow? Key idea: express a numeric computation as a graph. In key idea, we can express as a numeric computation as a graph. Graph nodes are operations with any number of inputs and outputs. Operations, any number of inputs and outputs, not limited. Limitation. It is not having any limitation. Graph edges are tensors which flow between nodes. Graph edges, tensors which flow between nodes. Programming model. H equal to ReLU Wx plus P. ReLU flow diagram. Add, we have to be add this one. Mat multiplication Wx. This one mathematical multiplication. Then add variables are stateful nodes which output their current value. Current value is the output. State is retained across multiple executions of a graph. Mostly parameters. Placeholders are nodes whose value is fed in at execution time. Or placeholders are nodes value fed in at execution time. Mathematical operations, matmul, multiply two matrix, add element wise, ReLU, activate with the element wise, rectified linear function, activate with the element wise, rectified linear function. 0, x is less than or equal to 0. X, x is greater than 0. This is the condition. Code. Import TensorFlow as TF. TF is for TensorFlow. BW. TF variable. It is nothing but variable. TF zeros 100 with weightage. TF variable. TF random underscore uniform 784 100 minus 1 to 1. X TF placeholder TF float 32 1 comma 784. H is the example. TF dot NN dot ReLU of TF of mat multiplication XW plus B. running the graph, CPU and GPU. It will run in CPU and GPU. Deploy graph with a session. To particular execution context, binding CPU, GPU, end to end. So far, build a graph using variables and placeholders. We have to make graph by using variables and placeholders. Deploy the graph onto session execution environment. Next, train model. Define loss function, compute gradients. Defining loss. Use placeholder for labels. Build loss node using labels and prediction. Prediction equal to tf.nn.softmax output of neural network. This one. Prediction. Label tf.placeholder of tf.float32 cross underscore entropy equal to minus tf dot reduce underscore sum of label asterisk log tf dot log prediction x equal to 1. Gradient computation, back propagation, train stripper. TF train gradient descent optimizer 0.5, minimize cross entropy. TF train gradient descent optimizer is an optimizer object. This is an optimizer object. TF train gradient descent optimizer 1R minimize cross entropy adds optimizations operation to computation graph. Optimization we have to be add for operation to computation graph. TensorFlow graph nodes have attached gradient operations. Gradient with respect to parameters computed with back propagation automatically. Descent principles. Data flow graphs of primitive operators. Defined execution two phases. Define program, that is symbolic data flow graph with placeholders. Executes optimized version of program on set of available devices. This is the two phases. First one is define program, second one is execute optimized version of program. Common abstraction for heterogeneous accelerators. Issues a kernel for execution. Second one allocate memory for inputs and outputs. Third one transfer buffers to a and from host memory. Dynamic flow control. Problem support ML algorithms that contain conditional and iterative control. Example recurrent neural networks and long short-term memory LSTM RNN. Solution add conditional if statement iterative while loop programming concepts. TensorFlow high-level architecture. Core in C++. Very low overhead. Different front ends are specific in driving the computation. Python and C++ easy to add more. Core TensorFlow execution system. This one. CPU, GPU, Android, iOS, and extra. TensorFlow architecture. Very low overhead. First one. Second one also. Here different from ends for specifying and driving the computation. Python and C++ today easy to add more. Here add. We have added. Detailed architecture. Training libraries, inference libraries, Python client, C++ client, C API, distributed